Okay, so good morning for another class, lecture number 10, yes. So I think we were looking at differentiable functions, right? So we looked at some of those theorems which you know, Rolle's theorem, right? And P-Rolle's theorem, right? So now, today I'm going to look at another theorem, which is law of mean, right? Which is pretty straightforward and it's kind of generalization. So basically, after that, we are going to look at Taylor series or power series. I think some of you might be knowing that it is also known as Madhava series, right? Because it was known in India. Okay. Quite early, right? So anyway, so and after Taylor series, it's all done, right? Then we are not going to look at any new topic because your question paper is also ready for 18th, right? So anyway, so I think after finishing this, I can probably revise the whole stuff for you so that you have some, you may be having tons of doubts and so on, right? Anyway, so let me start. So, okay. So what was Rolle's theorem? If f is a continuous function on a closed interval, a comma b on the real line, right? And it vanishes on the endpoints, right? And suppose derivative exists for the open interval, then there is a point C between A and B at which derivative is 0. Means you can draw at that point a tangent parallel to x-axis, right? So all these geometrical things are there anyway. So now, what are the some of the use or applications of these kind of results? You can find, for example, root of equation, right? I mean, at least if there is a root for some expression, right? Those kind of things can be done because, uh, wherever. So I think some of these applications I talked about, I mean, you can find it in the third tutorial, right? So you will see some of those things we have listed there. Uh, so that was proof was there. So I think I'll just mention the examples because it's very fairly straightforward, trivial. So if f of x is square root of 1 minus x square, where minus 1 less than or equal to x less than or equal to 1. So this function follows the property of Rolle's theorem. And you know that the derivative of f of x is minus x divided by square root of 1 minus x square. Okay. For minus 1 less than x less than 1. Okay. So f is not differentiable at the endpoints. And for this, c turns out to be 0. So f dash of 0 is 0. Okay. Simple application of Rolle's theorem. If we take another example, gx is equal to 1 minus mod of x, where minus 1 less than or equal to x less than or equal to 1. That is essentially mod of x less than or equal to 1. Then we have at the endpoints, this value is 0. And of course, g is continuous on closed interval minus 1 and 1. Now this function is differentiable everywhere in minus 1 and 1 except at x is equal to 0. So if you draw the curve of this function, because this property fails to hold, I mean, right, the differentiability at one of the point it is not differentiable. So this, so you will not be able to find a C for which the tangent is parallel to x-axis. So I think you can see the graph and everything. By the way, as I suggest, please use some of those mathematical softwares like Mathematica or MATLAB, right? Or Wolfram Alpha, you can just plug in and you can see the graph and so on, because that is quite helpful. Because some of you are not able to imagine the graph, right? Or if you have not done enough practice, it will be difficult for you to analyze the graph anyway. So that is the simple thing. So now we come to the next result, which is law of the mean. Third property. So first, the function is continuous. Suppose f is a continuous function on closed and bounded interval a comma b. So f is continuous on the closed interval a comma b on the real line. And suppose second property, the derivative exists for all x in open interval a comma b. It is differentiable. So function is continuous on the closed interval a comma b. Derivative exists for all interior points except the end point. Then there exists a point C between A and B such that derivative of C is f of B minus f of A divided by B minus A. Right. So this is, you can clearly see that it's a generalization of the previous result. Right. So derivative is nothing but sort of mean value, right? So you can see that f of B minus f of A divided by B minus A, right? So if you put, so if f of B is equal to f of A is equal to 0, you get the previous result, right? So how do we prove it? Now, this is, we can use Rolle's theorem to prove this kind of, we can use the previous result to prove it. It's not very difficult. So what we do here, suppose we take a function h of x as f of x minus f of a, f of x minus f of a minus f of b minus f of a divided by b minus a times x minus a, where a less than or equal to x less than or equal to b. I take this function h of x is equal to f of x minus f of a minus f of b minus f of a divided by b minus a times x minus a. If I plug in x equal to a, what will happen here? 0, right? If you put x equal to b, what will happen here? Again 0. So this function vanishes at the endpoint a and b, right? Since function f is differentiable, since function f is continuous on the closed interval a comma b, actually this function is also continuous. Everything will remain the same, right? So it's just a combination, right? And then we have function f of x is differentiable in the open interval a comma b. So is this function, right? So all the properties are satisfied. That means there exists a point C at which h dash of C is equal to 0, right? Now clearly h of A is equal to 0 is equal to h of B, and all properties of Rolle's theorems are satisfied. So using Rolle's theorem, there exists a point C between open interval a comma b such that h dash of C is equal to 0. Now what is h dash of C? You can just compute from the above expression is nothing but f dash of C. So h dash of C is nothing but h dash of C is nothing but f dash of C. I have to write slowly, otherwise there is a problem. Is equal to, minus f of B minus f of A divided by B minus A. And so this turns out to be 0. Okay. So we arrive at this result. Okay, so this is the law of mean, quite useful. So actually you will see that a lot of applications there. I'm not doing some of those applications, but especially in the tutorial 3, you will find some of those applications, right? And I hope they will be discussed because you have some clashes, right? I mean, last time you have not done tutorial, but I think over this week you have to do. There is no way out. Okay. By the way, don't go home actually, in between of the semester, it is going to hurt you. Okay. I think many of you are going home and that creates problem. Anyway, so now I think we can talk about, I mean, so I think you know some of these stuff. What is the power series expansion of sine x? X minus something something, right? You remember? किसी ने बता दिया, याद कर लिया, right? But how you arrive at that formula? Similarly, e raised power x is equal to 1 plus x squared divided by factorial 2 and so on, right? So these are the power series expansions, and they are, so now you can see that these are infinite series, right? Each of them are infinite series, right? So whenever you are summing infinite terms, the question comes about convergence. For what values of x actually this sum is valid, right? So can anyone tell sin x series is valid for what x? Sin x. 0. 0 तो होगा ही. Or e raised power x. I mean, you are using all these formulas, without worrying about where the x lies, right? So if you choose outside whatever is the domain of convergence, you will be in trouble. Okay. So these formulas are valid for certain values of x. So what are those values of x? Huh? What? Sorry. All real values. Correct. So the sin x is valid for all real x. So for all, so x, whenever x lies between minus infinity and plus infinity, the series is valid. So somebody has to prove it. How will you prove it? It's very simple. What you can do, you just now you saw some of those tests, right? Test of convergence of series, right? Apply one of them here, and you can see that whole thing will be valid if mod of x is less than infinity. You will arrive at this. So something called as radius of convergence is infinite, right? So it values for all x. Similarly for e raised power x, because you have the terms, so you can find the nth term. So then you compute the ratio test. Remember ratio test? Something is greater than 1, less than 1, right? So put the condition the series is convergent, and then find the value of x from there. So that is the way to find the radius of convergence when the series is convergent. Okay. So now that is one aspect. Okay. So series is given to you. You can test what are the values for which it is convergent, right? So question is, how do we find if there is a series? Whether there is a series expansion for all functions, right? So in mathematics, there is a one very powerful trick, which is known as, if you are working on some problems, you don't know certain things, assume that is x, right? Put it in the system and solve for x, right? Depending upon the conditions, right? This is known as power of algebra, right? So whenever you are in trouble, assume something which is you don't know, assume it is x, and then plug into the system. If there are two things which you don't know, you assume x and y and put into the system, see if you can solve it, right? That is the beauty, the power of algebra. The same thing we are going to use here. I will take a function f of x, and suppose there is a series. Okay, I will write down the series expansion and try to find out what is unknown, right? So let us see this approach. Taylor series or power series, right? Suppose f of x is a function, and I'm saying that for all x in some interval j on the real line, right? F of x can be expressed as, f of x can be expressed as a constant a0, the value we don't know, a1 time F of x is equal to a0. If I am writing it fast, it is giving me trouble, right? Write it slow. But okay, x minus a whole square plus dot 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 an x minus a whole raised for n plus dot dot dot. So I have assumed this function f of x has expression like this as a series. What is unknown? A0, A1, A2. Those are the values which I don't know. So I want function to be expressed a series like this. Okay? So basically, so for example, in case of e raised power x, what is the value of a? 1 or 0? In case of e raised power x, what is the value? 1 plus x square by factorial 2 plus x cube by factorial 3 plus x raised power 4 by factorial 4 and so on, right? So a is 0 there, right? Okay? And the powers are there. Okay? So in general, function f of x, so I can maybe write down. That way you will find it much more natural. So we know that e raised power x is nothing but 1 plus x square by factorial 2 plus x cube by factorial 3 and so on. So this is a series for e raised power x, right? So similarly, I am given a function f of x. Suppose it has series expansion like this for some point a. Okay. And what is known? I mean, you know x minus a, x minus whole square, everything. But what you don't know is ai's. A0, A1, A2, A3, and up to so on. This is an infinite series. So any idea how do we approach? How do we solve this? Because the solution should come from your thinking process, right? Huh? Multinomial? No. No. You have to. This is a algebra, right? I mean, you have to now solve for these coefficients. How do we find? Yes.
कोफिशिएंट फाइंड करना है हाँ तो सर a0 तो f of a डालने पे मिल जाएगा x की वैल्यू a डाल
Yes, that is first thing. So if I want to find capital A0, if I plug in x equal to a, all the other terms will go off. So we know the value of A0, right? What about the next one?
डिफरेंशिएशन कर दो
Yes, so you differentiate. So you differentiate it and then plug in x equal to a, you get the second term A1. Like that you can continue, right? See, very naturally it is coming, right? This is the power of algebra, beauty of mathematics, right? You can just, something you don't know, just assume and plug into the system and just see, right? Okay. Now, who tells you that this differentiation? Somebody told you or you already knew it? 12th mein padha tha. Okay. But otherwise, you require only beauty, right? You observe the beauty and then you know, right? You have to solve, right? So, this is a thing. But I think, while doing this, you have assumed that the function is differentiable any number of times, right? A couple of conditions automatically comes, right? And you can differentiate term by term, right? All those assumptions are there, but this is a good thing, good start. So let us do that. So these points I want to find, right? And so what is the method? So the thing is that how to compute AIs. So our method is plug x equal to a. If you plug in x equal to a, we get this portion goes to 0. We will have f of a is equal to, f of a is equal to a naught. Right? Second, then you differentiate. Suppose this call it equation 1. Differentiate 1 both sides. So you will get f dash of x is equal to a1 plus 2a2 times x minus a plus 3a3 x minus a whole square and so on. Again put x equal to a and you get f dash of a is equal to a1. Got it? So you again differentiate and then again put it x equal to a, you get the third term, fourth term, and so on. You can find all of them, right? Any question at this point? It's very straightforward. We assume that these are, some unknowns which we don't know, and then just plug in the value of x. Each time you differentiate, and then you get one value, right? So we have the power series. Sometimes these tricks, see, this is how the mathematics approach. So right now I'm not worrying about whether it is convergence, divergence, right? But at least I am able to find an expression. Now my job is to check whether it is convergent, divergent, how do you do those kind of things anyway? So here, so we will have, if you continue like that, nth derivative evaluated at x equal to a will be factorial n times an, right? So function, therefore, f of x is equal to f of a plus f dash of a divided by factorial 1 times x minus a plus f double dash of a divided by factorial 2 times x minus a whole square and so on. Right. This is a series. You can find these coefficients. Here we have assumed, number one, that derivative of x exists. And right hand side derivative can be computed. We can do term by term differentiation, right? Even if the series is infinite, we can do that. That's the assumption here, right? These two assumptions we have done in computing this. Now, can you apply ratio test here and tell me what is the radius of convergence? Anyone? Apply ratio test. Do you remember ratio test? What is the nth term? Nth term is, so should I write down the nth term also? Yes. This is the nth term, right? Then similarly, you can find n plus 1th term. Then you have to do un by un plus 1 or what? Something like that. And then take the limit. Un is means nth term, right? Here nth term is fna times x minus whole power n divided by factorial n, right? So this series is convergent for what? n minus 1 उससे पहले आएगा ना टर्म? No, this is first, second, so somewhere it will come, this kind of term will come or not? You are having a doubt about this term? Term will come, right? Whether it is n minus 1, n plus 1, doesn't matter, right? Doesn't matter, वो तो constant है वैसे भी, right? So what I'm saying that, you are saying that, okay, will it be another n minus 1 term or whatever term, I don't care. So you see what I mean? These are terms, nth term, you assume nth term, someone, take the ratio. So take one term, take next term, take the ratio and compute the convergence, right? दिक्कत हो रही है? कन्वर्जेंस सीरीज कौन अच्छे से कर सकता है? That ratio test. हाँ, an un whatever, हाँ, doesn't matter यार. So मैंने जो पता है greater than 1 बोला होगा, उन्होंने बताया होगा less than 1 होगा, right? अरे मेरे भाई, what I'm saying that in the concept there is no issue. I am saying that whether you take un by un plus 1 or you take un plus 1 by un, right? If you take un by un plus 1, they should be greater than 1, right? If you take un plus 1 by un, then it should be less than 1, right? That's the thing. Remember? I gave you one idea. It doesn't matter, it's all simple mathematics, right? Are you able to find something? Okay, अभी तुम लोग सब घर से आए हो, so maybe you have to take a cup of tea. ये करना radius of convergence कैसे निकलेगा, right? Otherwise, I will show you. You will see that radius of convergence of such kind of power series comes in terms of this coefficient. So ये है ना यहाँ पे. Actually, this will give you the condition on mod of x minus a. So mod of x minus a is less than something. What is that something that you need to find it out? Okay. Okay. What is this something? Mod of x minus a is less than something. Capital R. And actually, you see that in case of e raised power x, this value is infinity. So x lies between minus infinity and plus infinity. So when you take the calculations and so on, right? I've been giving you some hints, but you need to work out other details. Okay. By the way, for a is equal to 0, this is known as Maclaurin series. As I mentioned, these things were known in India a long time ago. So again, a t time problem. Find the Maclaurin series for the function e raised to minus 1 by x square. Of x, f of x is equal to e raised to power minus 1 by x square. This function is really interesting. Okay. How do you find the Maclaurin series expansion for this function at origin? I mean, you can plug into the series and so on and so forth. You see that the function is differentiable any number of times, but still no Maclaurin series exists. Okay. So I hope you will enjoy this beauty here when you do the computations, right? Okay. So anyway, so now I can talk something about the convergence stuff. So we have f of x is equal to f of a plus f dash of a divided by factorial 1 times x minus a plus dot x minus a whole is for n plus whatever left after this. I am just calling this expression Rn plus 1. And actually, you can show that as limit n tends towards infinity, this is known as remainder goes towards 0. After a certain number of terms, one can show that this remainder goes towards 0. Actually, I am going to show this with one approach. There are 3 different approaches to show this. And in fact, there's a different form of remainder you can compute. Okay. So I'm going to use, what is fundamental theorem of calculus? Have you heard this term? Fundamental theorem of calculus? JEE में नहीं पढ़ा है? Anyway. Okay, I will mention it. You can prove it again that epsilon delta business, but I'll just mention this result. Okay. So we are going to use that result to show that this remainder goes towards 0. So basically what I'm saying that when you are doing the series expansion after certain finite number of terms, if I put all other terms as a one function, I can show that the limit as n tends towards infinity, the whole thing goes towards 0. So actually you have the, basically the convergence thing can happen. So let me show you. We are going to show you what is known as Taylor's polynomial. But before that, let me describe fundamental theorem of calculus. By the way, I think some of these things will also be useful for you. What will happen if you compute limit x tends to infinity x raised to power n divided by e raised to power x? This value is what? See, on the numerator it is x raised to power n, sort of a polynomial kind of thing, na? One expression from polynomial. And the denominator there is the exponential function. Now, if I have to compute it, I'm giving a hint. If x tends towards infinity, what will happen? Obviously, both see e raised to power x also goes towards infinity, and x raised to power n also goes towards infinity, right? But which will go faster? Huh? Exponential. So denominator will go faster towards infinity. So the overall thing will become 0. Right? This is how you can compare, right? Also, there is another result which I am not going to prove, but I just mentioned that x tends to 0 plus 1 over x raised to power n e raised to power 1 by x is 0. N is a natural number. These limits are useful actually whenever we are dealing with this finding this Taylor series or something, you need to compute these limits, okay? Because you need to differentiate for the function. Function is given, you have to find the series, you need to differentiate. When you have to differentiate, you should know the formulas, right? So these are useful results. So I think a specific case is, suppose the function g of x is equal to e raised to power minus 1 by x when x is positive, and suppose at 0 it is 0. And if I ask you compute z dash of 0, this will be limit x tends towards 0, g of x minus g of 0 divided by x turns out to be limit x tends towards 0. Suppose we are computing 0 plus or whatever, e raised to power minus 1 by x divided by x, and this turns out to be 0. Okay, so these are some interesting things about limit. So this is also a very interesting function. You need to compute the Taylor series. Okay, I am going to now mention fundamental theorem of calculus without a proof. F is continuous on a closed interval a comma b, and suppose a function f of x is given as integration a to x f of t dt. Then f dash of x is f of x. Do you know about it? I think you must have seen this, right? In your most competitive exam, right? You might have seen this. The derivative is nothing but whatever is that variable that comes here, right? Now you can prove it. I'm skipping the proof. It is given in the notes also, but it's okay, even if you don't know, right? So this is a really interesting result. I'm going to use some of these results in for the Taylor series business, okay? Okay. Now formally, I'm going to do this Taylor series business. So it is a series of the form n is equal to 0 to infinity, nth derivative evaluated at a divided by factorial n times x minus a raised to power n, where mod of x minus a is less than r. R is known as radius of convergence. So when I said that you take this kind of expression and apply the ratio test, you can find what is R. Right? Okay, because you see that series is convergent. If the ratio test gives you something un by un plus n is greater than 1, so you know what is R, right? You automatically will see how do you get this thing, right? Actually, it turns out that it will be in terms of this coefficient which is there, another derivative of a divided by factorial n, right? So it's really easy thing to do. Now, if I take only certain terms in this series, I call it Tn of x as summation k is equal to 0 to n. So there are n plus 1 terms. This is known as nth degree Taylor polynomial. So degree is n. So I'm just taking n plus 1 terms, right? The first term. So total there are. So this is a degree n polynomial in this series, right? I'm taking only finite terms here. Okay. So let me give you some example before proceeding further. Let us take the function f of x is equal to e raised to power x. And suppose a is equal to 0. So we know that what will be t1 of x? Do you agree? 1 plus x, because e raised to power x is what? 1 plus x square by factorial 2 plus x cube by factorial 3 and so on, right? So t1x is 1 plus x, t2x is 1 plus x square by factorial 2, right? A polynomial of degree n. This is Taylor polynomial. Now, if this series is convergent, right? This series that we are showing you here, this series is convergent, then basically limit n tends towards infinity, Tn of x, Taylor polynomial, should give us function f of x. This should happen, obviously, because this is n terms, series is convergent. Remember, if I want to show that a series is convergent, I take certain finite terms and take the limit. If it exists, we say that the series is convergent, right? Here we are calling them Taylor polynomial, right? Certain terms, certain finite terms. And if the limit exists, we'll, and equal to the value of f of x, then we say that actually series is convergent, the value is f of x, okay? This is very natural thing to do. So here we write down Rn of x as f of x minus Tn of x. This is known as remainder of the Taylor series. Now, actually, we can show that. So, if we can show that this limit is equal to 0, I mean, as n tends towards infinity, if this remainder after n terms goes towards 0, then what will happen? This will converge toward f of x, right? So, we have the series expansion. So, the question is, I have to show this, that this expression goes towards 0. And this expression goes towards 0 under certain conditions on x, right? Okay. And that I am going to determine. So I am going to find a bound on the Taylor polynomial. And actually, you can show that the whole thing goes towards 0 as n proceeds towards infinity. So basically, this remainder, goes towards infinity as n tends towards, this goes towards 0 as n tends towards infinity, right? Any question? I think this is something not very difficult, but sometimes it's new. So yeah, any question? So you see, there is infinite series, power series given to us. I want to show that it is convergent, right? Or, so what I need to do, I take finite terms and take the limit, and it should converge to the value of the f of x, right? Okay. That is the idea. So there are different ways you can find this reminder. There are three forms which are there popular in the literature. I will just mention them, but I will only look at one of them, right? I mean, I don't want to do too much. First year में ज़्यादा नहीं, ठीक है, थोड़ा. So we'll just do one portion actually. So I think I will not be able to do it today, but in the next class. But so I want to just mention the main result. If f of x is nothing but Taylor polynomial plus remainder after n terms, and if you are able to show that limit n tends towards infinity, Rn of x goes towards 0 for mod of x minus a less than capital R. R is known as radius of convergence. In that case, then there is a series expansion, summation k is equal to 0 to infinity, kth derivative of a divided by factorial k x minus a raised to power k. Right. This is the main thing I want to show. That this remainder goes towards 0 for mod of x minus a less than some value capital R. I'll find out capital R later on, right? Okay. So that is known as radius of convergence. In case of sin x, cos x, e raised power x, what is the value? R is infinity. In case of 1 over 1 minus x, if you expand, what is the value? 1 over 1 minus x. 1 plus x square plus, remember? What is the, so 1 plus x square plus x cube plus x power 4 dot 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 up to infinity. What is the value? ये पढ़ा है, ये तो नहीं पढ़ा है, तो बहुत कॉमन है ना? हाँ हाँ, तो क्या होती है वैल्यू मालूम है? This value is 1 over 1 by x, right? Provided mod of x less than 1. Mod of x less than 1. सबको भूल गए हो बिल्कुल, right? हनुमान जी को उनकी चीजें याद दिलानी पड़ती हैं, शक्तियां तुम लोग भूल गए हो, right? So that radius of convergence for this series turns out to be 1. So when x lies between minus n and 1. So you can actually compute everything with this beautiful construct that we are doing, okay? I'm not going to do anything today now. In the next class, we are going to finish this Taylor series business, right? Got it? So given a function, you can represent it in the form of Taylor series if certain things exist, right? Certain conditions are met, and you can find the radius of convergence, okay? So I think we have done enough things. I just want to have a direct feedback. So are you finding difficulty or is it smooth? If you raise your hand, if you think that the whole course is difficult. कोई नहीं? अच्छा एक जना है. Okay, एक को देख करके बाकी लोग हाथ उठाते हैं. So this is the, okay. हाथ नीचे करो. Do you think it is beautiful? अच्छा. कुछ लोग तो हाथ उठा रहे हैं, कुछ लोगों को तो अभी भी, See, I just want to feel what you know. Anyway, कितने को बहुत आसान लग रहा है, ट्रिवियल? अरे तुम सब में हाथ उठाते हो? anyway, आसान नहीं लग रहा है, मुश्किल लग रहा है. एप्सिलॉन डेल्टा से दिक्कत हो रही है. ठीक है. So in the last class, I will probably again revise, and you can ask tons of questions, whatever, right? To me in the last class. Your paper is almost ready. I mean, it's ready. I have to just submit it. And one question is a bit non-trivial. 3 are a bit easy. So normally, initially I thought 2-3 questions difficult, but then I saw your faces, right? So 3 are easy. One is, at least I should be able to find some cream also in the class, right? So, okay, that's all. We'll meet in the next class. I'll finish this Taylor business where I'll show you that Taylor polynomial, how do you handle the Taylor polynomial. Thank you.